So this assignment is related to equilibrium constant Kc and Kp. The structure questions related to the topic. So in the first part, we have a nitrosyl chloride, which is a yellow gas that can decompose to form nitrogen monoxide and a chlorine gas. A sample of 2 moles of NaCl was heated in a sealed vessel at a certain temperature T. The volume of the vessel was 5 decimeter cube. When the equilibrium reached, we have 0.22 moles of nitrogen monoxide. We have to write first the expression for Kc. So Kc is the concentration of a product divided by concentration of reactant. And this is a homogeneous equation, like all the reactants and the product are in the same state. So we have to include all of them. Kc is equals to NO raised to power 2, the concentration of a chlorine, and then divided by concentration of nitrosyl chloride, NaCl, raised to power. Then we have to calculate the value of a Kc under these conditions. So this is the expression. Now, how to calculate the value of the Kc under these conditions? So first thing, because we need the concentrations. So what is the initial concentration? We have the equation is NOCl, that was forming 2NO plus Cl2. So we have in the beginning we have 2 moles. This will be 0 and this will be 0. Like initially we don't have all the, like there is no product present in the beginning. So that's why initially or the beginning we mentioned that we have 2 moles. According to the question, we have 2 moles of NaCl. And as the product is not mentioned, so 0 and 0. But when the reaction occurs, we have 0.22 moles of NO. Now, we want to find how many moles this is at the equilibrium. So what we will do first, we will find, because if this many moles are produced of NO, how many moles of NaCl reacted. So how to work out that? We'll take a ratio between NaCl and NO. So the ratio between NaCl and NO, that is 1:1, or we can 2:2, or we can also say 1:1. So 2 moles to 2 moles. So if we have 0.22 moles of a product, then X moles of a reactant will be used. So how many moles are used? Same 0.22 moles used. But we don't need how many moles are used, need how many moles are left at equilibrium. So how many moles are left at equilibrium? So if originally it were 2 and now out of 2, 0.22 are used up. So how many moles of nitrosyl chloride left? That is 1.78. So this will be 1.78. Then how many moles of a chlorine are formed? So again, we will use a ratio between nitrogen monoxide and the chlorine according to equation 2:1. So if we have 0.22 moles, this will be X cross multiply. So it will be half of it, it will be 0.11. So this will be 0.11 moles of chlorine will be there. That is formed. So using the mole ratio, we work out how many moles of a reactant reacted and then subtract the total moles from the beginning, subtract that moles reacted, so we know how many moles are left. Because this part we write moles which are left at equilibrium. And for product, like how many moles of a product are formed, so we use a ratio to get the moles of product. But as we like this is the mole, but we need the concentration. So what will be the concentration at equilibrium? Like these are the initial moles. This one will be the equilibrium moles, and then the concentration. To get the concentration is mole divided by volume. And what is the volume? They mention in the question that the volume of the vessel is 5. So this will be 5, this will be 5, this will be 5. So we divide all of them by 5 so that we get the concentration. The concentration will be 0.356 0.044 and 0.02. So this is the concentration of each. And in the beginning, the first part, we already uh, mentioned the expression for Kc, which is the product divided by reactant. So it is NO, Cl, then O, raised to power. So using this, we'll work out the value for Kc. So we'll substitute the values here, like we have all these values. So we'll just substitute in the final formula. So when we substitute in the final formula, the Kc, the concentration of NO, which is 0.44, and raised to power 2 square, the concentration of a chlorine is there, 0.022, and the concentration of nitrosyl chloride 0.356. So 0.356 and then square. And we just substitute the values to get the value for Kc. And what about the unit of the Kc? Kc will be about 3.36 into 10 power minus 4. 3.36 into 10 power minus 4. And what about the unit? How to work out the unit? Unit of concentration, like here it is mole per dm cube. So this will be mole per dm cube. And then square, this will be mole per dm cube. And this will be mole per dm cube. So this will cancel with this. So mole per dm cube is left. So the unit of this Kc 3.36 moles per decimeter cube. Then the volume of the vessel containing the equilibrium mixture in A was double, like now it is 10, keeping the temperature same. State the effect of this change of volume on the Kc and Kp are only affected by temperature. So there is no effect on the Kc. Kc won't change. It is only affected by temperature. For endothermic reaction, increase in temperature. So Kc only changes by temperature. So for endothermic increase in temperature, increase the value for Kc or Kp. Exothermic increase in temperature, decrease the value for Kc. And what happened to the concentration of NO, the moles of NO? Because if we increase the volume, means we reduce the pressure, and if we decrease the pressure, equilibrium will shift towards the side where more moles of gas are there. So when we check the total number of moles of the gas, on the reactant side we have 2 moles, and the product side 2 plus 1, 3 moles. So increase in volume, decrease the pressure, so it will shift the equilibrium towards side where number of moles are more. So in this case, the concentration of NO will increase. So what will happen to the concentration or amount of NO? That will increase. Then some data about the nitrosyl chloride are given, complete that with the data booklet. The enthalpy change of formation for NOCl, and then we just have to complete the table here using a data booklet. So it is plus 90.5 for element formation is 0, and the other one, that is 210. So using a data booklet, we complete and then calculate the standard enthalpy change of the reaction. So how to work out the standard enthalpy change of a reactant? So it is product minus the reactant. So when we work out the difference, the product enthalpy change of a reaction is there, and for when formation are given, so we'll have elements, like we'll add another link, that is element. So what are the elements here? Element will be nitrogen, element will be oxygen, element will be chlorine. Element form the reactant, and reactant form a product is same as element directly form a product. So according to Hess law, the overall energy change does not depend on the route or the path. So if we follow route 1 or we follow route 2, the overall energy change is not affected. So means when nitrogen, oxygen and chlorine react to form nitrosyl chloride, 2 moles. So 1 mole formation of a nitrosyl chloride, that is 51.7. In the beginning, it's given here 51.7. But here in the question, 2 moles are formed. So it will be 2 multiplied by 51.7. Then enthalpy change of this reaction we are defining, and when 2 moles of NO are formed and 1 mole of a chlorine, if 2 mole of NO formed, so that is 90.5. And 90.5 into when chlorine is there, but it gets for element is not formation, so 90.2 multiplied by 2. So if we this is a start of the cycle where 2 arrows are pointing out, and this one is the end of the cycle. So if we follow route 1 or we follow route 2, the overall energy change is independent of the route. So it will be 2 multiplied by 51.7 plus enthalpy change is equals to 90.2 multiplied by 2. So delta H will be equal to 90.2 multiplied by 2 minus 2 into 51.7. When we simplify, this will give us the enthalpy change of this reaction. It is plus 77 kilojoule per mole. Then we want the enthalpy. The next part, we need the enthalpy change of a surrounding. Use your answer to B1. Explain the total entropy become less negative as the temperature increases. Because the reaction is endothermic. So endothermic reaction, the total entropy is equal to entropy of a system plus entropy of the surrounding. And for entropy of surrounding, like entropy of the system is like a constant depending on reacted product. Surrounding is minus delta H by T. So what happens when the temperature increases? So the value of this delta H by T will decrease. So if the value of delta H by T will decrease, or we can say entropy of the surrounding will decrease, as a result, it will become less negative because it is negative due to entropy of surrounding. If this value decreases, a small difference is there. That's why the enthalpy of the total entropy will be less negative. And given expression relating the equilibrium constant to the total entropy and how the equilibrium constant changes as the temperature decreases, as temperature increases. So what is the relation between equilibrium constant? That total entropy is equals to R ln K. It means it increases with the temperature. So total entropy of a system plus surrounding is equals to R ln K. So when the value of the K increase, the total entropy of the system and the surrounding, like the total entropy, will also increase. And in part C1, standard entropies are there. Explain why the value of the standard molar entropy of all substances greater than 800 than at 298. So basically, why the entropy increases as the temperature increases, that's the question. Because when we increase the temperature, the particles will have more energy, greater kinetic energy, and means greater way of distribution of energy. So increase in temperature, increase the kinetic energy, which increase the number of the ways of energy distribution. So more ways, as the temperature increases, more ways the energy can be distributed. Then calculate the standard entropy of a system. So how to work out at 800? So we have the formula: entropy change of a system is product minus reactant. So we have the product here, like this is a continuation, the full question. So if you want the entropy change of a system, So the entropy change of the system is the product, the total entropy of the product minus the total entropy of the reactant. So for product, it will be 100. The table is given in the beginning, so that is 189.3 plus 2 into 231.2 minus 2 into 305.5. Because these 2 moles are there and the reactant. So when we simplify, this will give us the total entropy of the system, which is 63 joule inverse or joule mole inverse Kelvin. Joule mole inverse Kelvin inverse. That's a unit. Or it can be 43 or 40.7. When you simplify, it will be 40.7 joule mole inverse Kelvin inverse. And the next part, we need the entropy of the surrounding. So it is minus delta H by T. It means the enthalpy change divided by temperature will give us the enthalpy of the surrounding. So this is for system only, and surrounding we can also work out. So this was question 1 related to topic equilibrium constant Kc and Kp.